let's analyze a function x to the fourth minus 4x cubed using the first and second derivative test. First of all, find the critical values. To find critical values, we're going to find the first derivative of the function, which is 4x cubed minus 12x squared, and set it equal to 0. So set 5 equal to 0, or set this equation equal to 0. 4x cubed minus 12x squared equal to 0. Now we're going to do a little bit of algebra. So 4x squared or x minus 3 is equal to 0. It means that x is 0. X is, we get two possible values. I don't know which one is minimum and which one is the maximum. These are my critical values. One of them is 0 and the other one is 3. Well, we can take a look at the first derivative sign. See that here? This is my f prime, and this is the behavior of function f. And these are the x values 0 and 3. So we can plug in 0 and 3 into the first derivative of the function. Well, both of these are equal to 0. Well, if I use a negative number less than 0, like -1, nearby point, f prime at -1 is 4 times -1 to the third minus 12 times -1 to the second power, or f prime at -1 is -4 minus 12, or -16. I get a negative sign. What's the meaning of that? It means that my function itself is not decreasing. The derivative is negative. It means that I have a decreasing behavior for my function. Well, what if I plug in a positive number around 0, like +1? Now I'm going to calculate f prime at 1, which is 4 times 1 to the third minus 12 times 1 to the second. F prime of 1 is 4 minus 12, or -8. Hey, I still get a negative sign. It means that still my graph going down, decreasing behavior. Well, what if I plug in, for example, a positive number on the right-hand side of 4, on the right-hand side of 3 by 4? So what is f prime at 4? What is the sign here? Here I have 4 times 4 to the third minus 12 times 4 squared. Well, here I have 4 times 16, or 16 times 16, minus 12 times 16. If I factor out 16, I get 16 times 4, which is positive. Very well. So since the derivative is positive, it means that my function starts going up. What's the meaning of that? It means that at 3, I have a minimum value. So when x is 3, at x equals to 3, we have a minimum. Well, what is this 0 then? Is it my maximum? Of course not. Remember, the graph is just decreasing, keeps going down. And then at 3, it goes up. So at x equals to 3, we're going to end up having a minimum. By substituting 3 into the original function, you get your minimum value. Now we're going to use the second derivative and check to see what do we get from the second derivative. So the second derivative of the function is 12x squared minus 24x. If I set the second derivative equal to 0, I get 12x squared minus 24x equal to 0, or 12x. X minus 2 is 0. It means that x is 0, or x is 2. I'm looking for inflection points. All right. If the sign of the second derivative is positive, I have a minimum, and if the sign of the second derivative is negative, I don't have a maximum. So let us analyze the sign of the second derivative here. So I'm going to have the second derivative of the function, and then I have 0, I have critical values, 0 and 2. I already know at x equals to 3, I'm going to end up having a minimum. If I use a small negative number around 0, like -1, the sign of the second derivative is actually, well, here I have 12 plus 24, which is of course a positive number. You just see that it is positive. It means that the graph concaves up. That's the behavior of your function. So your function f is going to concave up. Concavity upward. Well, if you plug in, for example, a positive number like 1, the second derivative at 1 is going to be 12 minus 24, which is negative. So it starts concaving down. Down. If I plug in, for example, 3 into the second derivative of the function, I have 12 times 9 minus 24 times 3. Okay, so here you have 108 minus 72, which is obviously positive. So again, if concave up. So let's take a look at the behavior of this function. These are the things that we know. We know that at x equals 3, we have a minimum. And we know that the behavior of the function is concave up, concave down, and then concave up again. So let's try to graph this without looking at Desmos or any other websites. So my x-axis, and this is my y-axis. I know at 3 I have a minimum. So if I plug in 3 here, I get f of 3, which is 81 minus 4 times 27, or 81 minus 108 gives me, I have negative, I have 7, negative 20. So let's just continue this graph down. At 3, I have, suppose to negative 27 is right here, negative 27. If I plug in 0 into the function, it's going to be 0. And I know that this graph starts continuing upward, right? So when x is equal to 3, the sign of the second derivative is positive, and at the same time, I know that the graph has a minimum, and it passes through this point. Let's take a look at the values that we found. Before 0, the function concave up, right? Have some format of concavity. Concave up. Then start concaving down. So we're going to just make some adjustments to this graph a little bit so that the graph concaves down. And then it reaches its minimum and start concaving up again. So this is the possible behavior of our function. We can use Desmos and double check it. So let's take a look at Desmos together. Here we have the function x to the 4 minus 4x cubed. Well, as you can see, this is the behavior of your function. It concave up, then concave down, then it reaches to its minimum, and then concave up again.